Welcome back, Patriots. I know it has been a while since y'all have looked at any math, but that's fine. That's why we did an easy lesson before Thanksgiving break. And so now we are going to get back into the thick of things. So before Thanksgiving break, all we covered was the basics of inequalities. We talked about how to graph them, open dot, close dot, shading left, shading right, all that sort of stuff. Today we're going to move on to solving inequalities. Now notice I don't say solving equations because all these are going to be set up like equations, but instead of an equal mark, they're all going to have the inequality symbols on there. So before we actually get into that, I want to have you guys think through a little bit of this with me. We've got a whole bunch or a whole list of items over here on the left, and notice they are all true. So 2 is less than 5, 3 is less than 9, etc. I'm going to make a small change to all of these. Now, when I say a change, I mean, like for this one, I'm going to add 1. And whatever you do to the left, you must also do to the right. So if I add 1 to the 2, I get a 3. If I add 1 to the 5, I get a 6. And we're going to use the exact same inequality symbol. So here we had a less than, here we had a less than. And we're going to determine, did that change that I made to it change its truth value? So what I mean by that is 3 less than 6? Yes. And so therefore it is still true. All right. Now let's subtract 1. Well, -3 minus 1 is -4 is less than 6 minus 1 is 5. Is that still true? Yes, it is. Now let's multiply by 3. -2 times 3 is -6. 5 times 3 is 15. And is -6 less than 15? Yes, still true. All right, now let's multiply by -3. 1 times -3 is -3 is less than. 4 times -3 is -12. Now, is it true that -3 is less than -12? No, because remember on our number line, here we've got 0, there's -3, there's -12. Well, 3 is actually bigger than -12, so that one is actually false. Okay, now let's do our next one. Divide by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And is 1 less than 2? Yes, still true. Now let's do -3 divided by -3. 1 is less than 9 divided by -3 is -3. Now, is that one true? No. So, across all of these, notice what happened. If I added or subtracted, it does not change the truth value. If I multiply by 3, it does not change the truth value. If I divide by 3, it does not change the truth value. The only thing that changes the truth value is multiplying by -3 or dividing by -3. In particular, the thing that's important there is the negative sign. Anytime that I multiply or divide by a negative sign, that's going to cause some issues with my truth values of the entire inequality. So that's going to bring us into this idea right here, the golden rule of inequalities. Where'd it go? Okay. If you multiply or divide by a negative number, you must flip the inequality sign. And you'll get lots of practice as we go through there today. So as we're solving our inequalities here, we're going to follow a 5-step process. Now, some of these all kind of go together. And honestly, steps 2 through 5, you're going to do very, very quickly. Step 1 is going to take up most of your time. Step 1 is isolate the variable. What that means is get x, all the x's on one side, all the numbers on the other. Normally in an equation you would have x equals. However, in this case you're going to have x is less than, x is greater than, something of that nature. Okay, step 2. Make sure the variable is on the left. And when I say that, I mean we want x is less than or x is greater than, not x on the right. Okay, so we want x is less than a number or y is greater than a number. The reason we do that, by the way, is to make all of our arrows pointing consistent, so we don't make mistakes on that. Okay, then for the graphing portion, circle a number on the number line. Step 4 will be to use an open or closed dot. And then step 5 is draw your arrow left or right. Now, I said that most of your time is going to be spent right here on number 1. When I say that, what I mean is, back in previous units, back when we had solving, where was solving? Man, that's been a while ago. Whew, way back here in unit 2. Let's go with 2-3. Yeah. We had all of this stuff that we did about are there any parentheses, any like terms, that whole process. You're doing this exact same process for inequalities, but now this entire thing, all of that, is being lumped together in just this step 1. We're taking for granted, we're assuming that you guys know how to solve equations and you're going to be doing those steps all the way through. So let's jump down and actually do some examples here. Okay, open circle and closed circle. Which inequalities are going to give me open circles? Which one's going to give me closed circles? Which one's which? Oh boy, we got to think back to a week ago. Open circles are less than or greater than. Closed circles are less than or equal to or greater than or equal to. Okay, now let's solve and graph this, and we're going to be graphing it on this number line down here below. So, step 1, isolate the variable. So you got to go through all those questions. Are there any parentheses? No. Oh, actually, take it back. Before we start this, the inequality sign is going to behave exactly like the equal mark in every way except for that golden rule we talked about earlier. So we draw the line right there. Now, any parentheses? No. Are there like terms on the same side of the equation? No. Are there variables on both sides of the equation? Yes. We've got to clean that up. Now, we've typically done the which one's Texas thing. It's starting to matter less and less about which one you move between. I really don't care. On inequalities, it works out best if you always move variables to the left. But if you move them to the right, that's not a big deal. That's why we've got step 2 up there. Make sure the variable's on the left. So I'm going to move it to the left just to keep it consistent here. And then I'll do one where I'll put it on the right later on. Okay, so if I'm going to move it over to the left, I'm going to subtract the x on both sides. That's going to give me 5. Negative 3x minus x is minus 4x. Now, instead of an equal mark, I'm going to write whatever inequality sign I had. So less than or equal to 13, and those two canceled out. Now, next question was, do I have a constant being added or subtracted? And yes, I do. I have this 5. So I'm going to subtract 5 on both sides. Negative 4x is less than or equal to 13 minus 5 is 8. Next question was, do I have a constant being multiplied by the variable? And yes, I do. So divide by it. And I'm left here with x, and 8 divided by 4 is negative 2. But because I have divided by a negative 4, that invokes that golden rule of inequalities. So whenever I divide by a negative number, I have to flip the inequality sign. So my inequality sign is going to get flipped around the other direction and be greater than or equal to. Now step 2 was make sure the variable's on the left, which we've already done, so we're good there. Step 3, circle that number on the number line. So I'm going to put my negative 2 on the number line, and then I am going to circle that. Now, open dot or closed dot? Well, less than or equal to is a closed dot. And then shade right or left? Well, if x is greater than or equal to, it's got to be things bigger than negative 2, so I'm shading right. And again, the reason why we put our variable on the left is because this symbol that I have here, the greater than or equal to, I could basically pretend that's an arrowhead and it'll point the right direction. So that's why I put them on the left. Okay, before we go on, I am going to change a couple of examples here. Not because there's anything any mathematical reasons for it, but just because when I made these examples, I jacked up, and I'll tell you why at the end. But for now, we're just going to correct these. So what I want you to do is here on number 3, I want you to get rid of that greater than sign and make it a less than sign. Also, we want to do the exact same thing with number 6. Get rid of this less than or equal to and make it a greater than or equal to. So you should have flipped those signs on 3 and 6. And again, the reason is not because there's anything mathematically wrong with them. I just need a different style of example. All right. Rules for solving inequalities are the exact same as solving equations, except when you multiply or divide by a negative. Okay. So let's go through here. Number 1. First step on this one, add 7. Gives me 4x is greater than or equal to 8. Next step, divide by 4. Gives me x is greater than or equal to 2. Now, I did divide, but I divided by a positive number, so that does not invoke that rule. So we leave the inequality sign as it is. Variables on the left, so I'm good. I'm going to put that number on the number line and circle it. Now I decide open or closed. It's greater than or equal to, so it's closed. And now I decide right or left. And it's greater than, so I go right. Okay, moving on to number 2. We are going to, again, treat that as if it is a... No, Google, I'm not talking to you.
Here's a matching video.
No. I don't want a matching video. I need to stop saying okay, I guess. Okay, treat that less than sign like an equal, or like an equal to. Now we're going to divide by -6, which gives me x. Oh, that's a -6. And 24 divided by -6 is -4. But since I divided by a negative, that invokes my golden rule, and so I flip that sign around. Now, x is on the left, so I'm good on that front. I've got a -4. I'm going to circle it. And this time, since it's just greater than, I do not fill it in. I leave it as an open circle. And greater than goes to the right. Okay, any questions so far? All right. Number 3. Here, I'll leave those up so you can still see them if you're trying to catch up. Number 3, remember you should have already flipped that sign around. Let's go ahead and draw our thing there. And now let's subtract 2. So x over 10 is less than negative, no. Is less than 10. And now remember that the fraction bar is nothing more than a division symbol. So that says x divided by 10. So the inverse of dividing by is multiplying, which gives me x and 100. And even though I multiplied by a positive, so it does not apply, or the rule does not apply, so I leave the sign alone. Okay, now x is on the left, so I'm good on that front. I'm going to go ahead and put my 100 there. Circle it. Now, what do you think? Open or closed? Open. And left or right? Okay, this is less than, so we're going to the left. All right, number 4. This one has a different first step because we have the parentheses there. We've got to distribute. Gives me 2 times 3x is 6x. 2 times -4 is -8. Is greater than 16. Now we're going to add our 8. Gives me 6x is greater than 16 plus 8 is 24. And now divide by 6, and I get x is greater than 4. Again, special rule is not invoked because of it being positive. X is on the left, so I'm okay. Circle the 4. Leave it open because it is not equal to, and then greater than goes to the right. Okay, number 5. Subtract 8. Gives me -2x is less than or equal to -4. We're going to divide by -2. -4 divided by -2 is +2. But I divided by my negative sign, so I've got to flip the inequality sign. Variables on the left, so I'm okay. Here I've got a 2. I'm going to circle it and then make that a closed circle because it's equal to. and then greater than goes right. And now, number 6. This one's probably our most complex one of the entire page. First thing we got to do is distribute the 3. And actually be careful because the sign goes with it, so you have to distribute the negative 3. So 2w gets written down. Negative 3 times w is negative 3w. Negative 3 times 7 is negative 21. Greater than or equal to 30. Now we've got like terms to combine. We've got these two. That's going to give me 2w minus 3w is negative w minus 21 is greater than or equal to 30. Now we're going to add 21 on both sides, and that gives me negative w is greater than or equal to 51. And now right here, I got a lot of students who will just freeze at this point because there's no number there. But remember, negative w is the same thing as negative 1w. So we're going to divide both sides by negative 1, giving me, and I'm going to jump over here now, w, since we divided by a negative, we have to flip around, less than or equal to 51 divided by negative 1 is negative 51. We got negative 51 on the number line, circle it, got an equal to, so I shade it, and then less than or equal to goes left. And now that we've done those, I can zoom out and you can see why I had you change number 3 and number 6. Notice every single one of these is pointing to the right. I messed up and forgot to put any less thans on there. So I had to change those just so we could have some that go to the left. Now I also realized that I said we were going to come back and do one where we had to rearrange it and we had the variable on the right. But I didn't have any in this set on the right-hand side of the page that had a variable on both sides. So in order to do that, to give you guys that example, I'm going to redo this one and do it a different way just so you can see what happens. Here I started off by subtracting x. I'm going to do the other way around this time. I'm going to add the 3x to both sides, just so you can see what happens if I put it on the right. Okay, so whenever I do that, I end up getting 5 is less than or equal to 13 plus 4x. Now I'm going to subtract the 13. 5 minus 13 is negative 8 is less than or equal to 4x. Now we divide by 4. And that gives me negative 2 is less than or equal to x. Now, you'll notice that these two are essentially mirror images of each other. Okay? By the way, that is the reason why you have to flip the inequality when you divide by a negative sign. Because it's essentially what's happening there is you've moved the x to the wrong side and you're having to correct that. If I had this and I was going to correct it, I would just mirror the whole thing over, put the x on the left, put the negative 2 on the right. But in this particular one, the x is bigger, so I have to make this one reflect that as well. The x is larger. So depending on whether or not you divide by a negative or you flip the inequality sign around, either way you're going to end up flipping the inequality sign. So that's why that's there. Okay, 3 word problems and then we're done. You plan to buy a bicycle that will cost at least $180. Now, first off, we're going to do these word problems very similar to how we did them last unit. We're going to have rates, starting values, and totals. So this 180, does that sound like a rate, starting value, or a total? That's going to be a total because that's a total price for our car. You've saved $38. Well, rate, starting value, or total? That's a starting value. And your parents have given you $50. Well, that's another starting value. If it had said $50 per month, like an allowance or something, that would be a rate. But if you're giving you one time $50, that's a starting value. Now, whenever I write this, I'm going to have the 180, and it says at least. Well, what that means is that 180 is the smallest amount, so our inequality sign has got to go the other direction. It's got to make 180 be the smaller amount, and the amount of money we have to save as the greater amount. So now I start plugging in $38 plus $50, and now I have to save some more, and I don't know how much that is, so I'm going to make that my variable x. Okay, now we're going to solve. Let's combine like terms. 38 plus 50 is 88 plus x is greater than or equal to 180. Subtract off the 88, and I get x is greater than or equal to 180 minus 88 is 92. So how much more money do you need? At least $92, depending on the cost of the bicycle. Okay, number 8. Now, an elevator can hold at most 4,000 pounds. Now, at 4,000 pounds, rate, starting value, or total? Yeah, that's a total. Now, if it holds at most 4,000 pounds, that means that anything I put inside that elevator is going to be smaller than 4,000. Okay, a worker needs to move supplies in 50-pound boxes. Well, 50-pound boxes, rate, starting value, or total? Well, if each box is 50, then that's going to be a rate. The worker weighs 160 pounds. So it sounds like the worker is getting on the elevator with the boxes. So is that the 160 pounds rate, starting value, or total? That's a starting value. Now, that would be different if we said we had multiple workers getting on that each weighed 160 pounds. But it doesn't. We just have one worker, so that's our starting value. So we've got the starting value of 160 plus 50 times the number of boxes. Okay, what is the greatest number of boxes that she can move in one trip? We're going to solve this inequality. Let's subtract the 160 out, and we're left with 50x is less than 4,000 minus 160 is 3,840. Now, somebody with a calculator help me out. I'm going to divide this by 50. What's 3,840 divided by 50? What is it? 76.8. Okay, so 76.8. So x has got to be less than 76.8. Well, if I want the greatest number of boxes, can I put 0.8 of a box on there? No, they're all whole boxes. So the greatest number of boxes I can put on there is 76. If I put 77 boxes on there, I've got too much weight. All right, last problem. And I apologize to all my people watching this video. This is the longest video we've had all year long, I think. We're at 30 minutes right now. Okay. On a work trip, you make $27 an hour. Rate, starting value, or total? Rate. Plus a $30 travel reimbursement. What's that one going to be? Well, we're taking one trip here, so we're going $30 is going to be our starting value. If it was multiple trips, it could also be a rate as well. How many hours would you have to work to make greater than $300? Well, the 300 is my total. So I've got 30 plus 27 times the number of hours. And then I've got 300. And if I'm wanting to make greater than 300, then I need my inequality sign to face the amount of money I make because I need the money to be bigger than 300. All right, last solving step gives me 27x is greater than 270. Divide by 27 gives me x is greater than 10. So how many hours do you have to work to make more than $300? More than 10 hours. So 11 or more. I guess you could probably do half hours, maybe quarter hours, depending on how you get paid. But that's it. Good luck on the assignment. Let me know if you have any questions.